My name's Sarah Clinch from the University of Manchester.
I'm Nigel Davies from Lancaster University.
I'm Marc Langheinrich from UC Lugano.
Together, we're presenting work entitled Scheduling Content in Pervasive Display Systems, in which we propose a novel architecture that decomposes display scheduling into 3 distinct stages. In so doing, we reduce complexity, allowing developers to isolate issues specific to each stage and utilize different techniques to overcome them. Our research was conducted in the context of the world's largest and longest-running research display testbed. Pervasive display scheduling is the process of determining which content item should be presented at which point in time and on which display. Display platforms are near ubiquitous, and none would have been realised without some fundamental decisions about scheduling. In early display deployments, this was relatively simple. But more recently, these scheduling decisions have become increasingly complex. Deployments have scaled up, creating new requirements, for example, to support synchronized orchestrations across multiple displays. Simultaneously, a desire to adapt display content based on transient context, together with requirements for interaction, mean that deterministic schedulers may no longer be appropriate. Implementing new schedulers that provide complete coverage requirements is becoming an insurmountable barrier for researchers. Furthermore, the last decade has brought visions for open public display networks that share and accept content from multiple diverse sources. These emerging display platforms will require new forms of scheduler that go beyond those currently available. Based on a comprehensive literature review, our paper identifies 11 requirements for display scheduling, together with the key approaches taken to date. We observe that despite 40 years of effort, none of the scheduling approaches come close to realising the requirements for future multimedia signage. We describe these shortcomings more completely in the paper. In light of our requirements analysis, we propose a novel multi-stage approach to scheduling. Our key insight is that the scheduling problem needs to be decomposed. While prior approaches have considered the task of scheduling to be a single monolithic process, we suggest instead that there are 3 distinct sub-processes: high-level goal setting, filtering, and selection. Implementation and evaluation of this model is given in the paper. For the purposes of this presentation, we will focus on providing a complete description of the 3 distinct stages. Our staged model begins with high-level goal setting, in which the scheduling process executes a resource inventory, i.e. what are the displays and content that form the scheduling context, and the gathering of stakeholder expectations. These stakeholder expectations may pertain to displays or the network as a whole, for example operating hours or no audio periods, to patterns of visible behaviour across the network, for example to show advertising content no more than 10% of the time, to the behaviour of individual content items, for example to always show the lunch menu at noon, or to interactions between displays and content and their environment, so for example to avoid descheduling content that is presently receiving interaction. The goal management component integrates policies expressed by stakeholders together with the inventory data and exports these in a format to be processed in subsequent stages. In our example implementation, both are exported as a content descriptor set. You can see the paper for more details. During the filtering stage, the scheduling process attempts to restrict the content by removing all items that are inappropriate for playback. We can think of the filtering stage as having only 2 inputs: the content items with their associated constraints, i.e. the output from the previous stage, plus a set of contextual data, including sensor feeds. If the constraints associated with the content item clearly cannot be met, then this item will not progress any further through the scheduling process. While in some settings the resulting content may only be a single item, it is likely that in most cases multiple items will remain. The resolution of these to a final decision is made in the selection stage. The selection stage operates over a set of eligible content items, each of which has already been determined to be valid for playback in the target context. During selection, the goal is to reduce this set to a single content item to be shown on the given display. To achieve this, the selection process revisits the policies and parameters specified during stage 1. Contextual information may also be used to inform decision-making. Since there are potentially a complex set of coexisting and conflicting policies, our implementation leverages prior work on the use of lottery scheduling in pervasive displays. This is explored in depth in the paper, but essentially ensures a probabilistic outcome. So that's our architectural model. Why does this matter? Firstly, since scheduling itself has rarely been the primary concern of most pervasive display systems, the community is yet to agree on either a common vocabulary or a set of grand challenges for future research. We believe that our articulation of these 3 stages can help future research consider each stage with equal importance and promote conversations that are founded on a common understanding. Second, we suggest that subdivision of the scheduling problem provides accessible entry points and allows developers to focus their attention on innovating within the construct of the articulated stages, rather than trying to do everything in a single approach. Further work is, however, needed to determine the interfaces between the three stages. Thirdly, the separation of concerns presented in our architecture provides a new opportunity for the combination of multiple scheduling techniques. In our own implementation, lottery scheduling offers an elegant way of allowing multiple competing or complementary policies to coexist. So at the beginning of this talk, we suggested that emerging display platforms are generating requirements beyond the capabilities of current schedulers. We hope that the presented model helps to facilitate new innovation in scheduling to meet these needs. Such work may include the resolving of competing scheduling requirements from different stakeholders. This could encompass multiplexing, not just in a single dimension, but simultaneously over different channels. Analytics-driven scheduling that leverages large and diverse data input, so for example using mobility data to shape scheduling decisions, which in turn are intended to alter pedestrian movement in the environment. And viewer-centric scheduling, in which scheduling moves from show this content item 10 times on this display to make sure that this viewer sees this content item 10 times. And with that, I'm going to conclude the talk. We look forward to taking your questions.